Hello friends, I welcome you in lecture number 23 on logic. In lecture number 22, we have discussed the method of finding principal conjunctive normal form using truth table. In this lecture, we will obtain principal conjunctive normal form of a given formula without using truth table. So before discussing that method, we just recall these logical equivalences. We know that if we have statement variable p and if we take conjunction of p with its negation, then this is always false. That is, we can write p and negation p is always logically equivalent to capital F, and that is easy to understand. Suppose I consider truth table for p and negation p, then because we have only one variable, there are two possible truth values t and f, and for negation p we will have f and t. And because we are using conjunction of p and negation p, we know that this is going to be true if and only if both are true, otherwise it is false. So here negation p is false, therefore this is false. Here p is false, therefore this is false. This means p and negation p is always false, therefore we can write that p and negation p is logically equivalent to f. Similarly, we can write that if we consider p or f, then that is always logically equivalent to capital P. That also we can understand in a similar way. We consider truth table. For p there are two possibilities, true and false. For f it is always false, and we are joining by OR operator or disjunction, and we know that disjunction is true if at least one of these two is true. So here p is true, therefore this is true. Here both are false, therefore this is false. And what we obtain, this is nothing but this variable p. So we can replace p by p or f, and we can replace f by p and negation p. So we will keep in mind these two logical equivalences that we will use in writing the principal conjunctive normal form. P and negation p is always logically equivalent to f, and p or f is always logically equivalent to p, and we will use distributive laws whenever required. So we understand the method with the help of this example. Obtain the principal conjunctive normal form of the following formula. First one is negation of p or q. So we start by applying De Morgan's law. We can rewrite this as negation p and negation q. This is using De Morgan's law. We know that in normal form we do not allow negation operator outside the bracket. Here negation is outside p or q, therefore first we are applying De Morgan's law. Now we want to write down principal conjunctive normal form, and we know that principal conjunctive normal form is nothing but conjunction of max terms. And what are the max terms for two variables? If you recall, for two variables we have these four possible max terms: p or q, p or negation q, negation p or q, and negation p or negation q. And if we take conjunction of these max terms, sum of these max terms or all of these max terms, then that conjunction is our principal conjunctive normal form. So in short, PCNF is conjunction of max terms only. Now here I have to write down the conjunction of max terms. Here we can see we have conjunction of negation p and negation q, but this is not max term and this is also not max term. So we have to write down the given formula as a conjunction of max terms. So here q is missing, here p is missing. So what we can do, so that we obtain conjunction of max terms. So we will start by writing negation P as negation P is logically equivalent to negation P or F. We are using this logical equivalence. We just explained that we can write P or F is always logically equivalent to P, or P is always logically equivalent to P or F. Therefore, we can write that negation P is logically equivalent to negation P or F. Similarly, here I can write negation Q is logically equivalent to negation Q or F. So here I have used this logical equivalence. Now I will use this logical equivalence. I have just explained in the starting of this lecture that P and negation P is always false. So we can replace capital F by P and negation P, or by Q and negation Q as per our requirement. Now if you observe, here Q is missing, so here I will replace capital F by Q and negation Q. I have replaced capital F by Q and negation Q, and here I will replace capital F by P and negation P. So I am writing here negation Q or P and negation P. So we are using this logical equivalence here. Now in the next step, we apply distributive law. This I can rewrite as negation P or Q, this and in between, and negation P or negation Q. I have applied distributive law of logic to this negation P or Q and negation P or negation Q, and they are connected by this AND operator. Similarly, this we keep as it is, and again we apply distributive law here. So I will write negation Q or P, negation Q or P, AND operator in between, and then negation Q or negation P, negation Q or negation P. Now this I can check that whether any max term is repeating or not. So let me check. Here I have negation P or Q, and there is no other negation P or Q. Similarly, here I have negation P or negation Q, and this is also equivalent to this one. Using commutative law, I can rewrite this as negation P or negation Q. So we will not write this, we will not repeat max terms, and this is negation Q or P, and there is no other max term which is similar to this. So in the next step, using commutative law, I will not write this negation P or Q and negation P or negation Q, and using commutative law, this I can rewrite as P or negation Q. So what we have used here, we have used that negation P or negation Q, that is this max term, is logically equivalent to this one by commutative law, negation Q or negation P. And we have used this fact also, that if we have P and P, then that we can write as capital P. So that we can understand, again here also I am writing negation P or negation Q, that is this term that I am considering with this, that is negation Q or negation P. Now this is logically equivalent to negation P or negation Q, and using commutative law, this I can rewrite as negation P or negation Q, and using this property I can write this as negation P or negation Q. I have used this property here. P and P is logically equivalent to P. Now you can see here we have all of these are max terms and they are connected by conjunction. Therefore this is conjunction of max terms only, and therefore it is required principal conjunctive normal form. We have conjunction of these max terms only in this line. So finally we have obtained our principal conjunctive normal form. We can understand another example also. Here I have negation of P implies Q. So first we can use this logical equivalence. P implies Q is logically equivalent to negation P or Q. So if I use this logical equivalence, then first I will replace P implies Q by negation P or Q. Now here I have negation outside the bracket, therefore I will use De Morgan's law. So whatever we are using, that we have to mention in the bracket. Now we are using De Morgan's law. Here I have negation of negation P or Q. So that is going to be negation of negation P, that is capital P, or will be replaced by and negation of Q. So now we have P and negation Q. So this is conjunction of P and negation Q. So it is not in principal conjunctive normal form. In principal conjunctive normal form, we require the conjunction of max terms only. So again we will use this formula. We can write P as P or F, or P or F is logically equivalent to P. Therefore I will replace this P by P or F, and here I will replace this Q by this negation Q by negation Q or F. Now we will replace this F by P and negation P. We know that P and negation P is always false, and here I have P already there, so this I will replace by Q and negation Q. So here I am writing Q and negation Q, this AND operator as it is. Here I have Q variable and P is missing, so this F I am replacing by P and negation P. So here we have used this logical equivalence. Now we apply distributive law for this. This I can rewrite as P or Q and P or negation Q. P or negation Q. Then we apply distributive law here. We have negation Q or P and negation Q or negation P. This we have written using distributive laws. Then we will check whether we have any repeated max term or not. First we start by checking for P or Q. So there is no other P or Q here. Then P or negation Q. So you can see here I have P or negation Q. If I apply commutative property, then negation Q or P is logically equivalent to P or negation Q. So we will not write this. And here we have negation Q or negation P, that is not repeating. So now I will not write this, and I will write remaining max terms P or negation Q and negation P or negation Q. So what I have used here, I have used commutative law. So here I will write using commutative law, and I have used this property also. P and P is logically equivalent to P. So using commutative law, I can write this negation Q or P as P or negation Q. So I will have P or negation Q and P or negation Q, that I can rewrite as P or negation Q. So there I have used this logical equivalence. Now we can see that all of these are max terms involving two variables and they are connected by AND operator. So this is conjunction of max terms, and therefore we can say that this is required principal conjunctive normal form. So in this way we can find out principal conjunctive normal form without using truth table also. If you have three variables, then you have to write max terms in such a way that your max terms cover all the three variables P, Q, R, then P or negation Q or negation R, like that. So for three variables we will have 8 max terms, and principal conjunctive normal form for three variables is conjunction of max terms out of these 8 max terms. So this is all about this session. In this session we have discussed how we can obtain principal conjunctive normal form without using truth table, and what we have used this logical equivalences, that P is always logically equivalent to P or F, and F is always logically equivalent to P and negation P, and we have used De Morgan's law whenever required. We have also used distributive laws. So using all those logical equivalences, we can find out principal conjunctive normal form of a given formula without using truth table. So this is all about this session. We will continue in this lecture series of logic. Thank you.